In this video, I'm going to be doing a few more examples of the use of the chain rule for finding derivatives. So in the first example, we have a radical in the denominator, and the quantity underneath the square root sign is being raised to the third power. So it would be helpful to rewrite this, first of all, as 16 divided by 2x squared plus 19x to the 3/2 power. Then it would be helpful to rewrite that once again as f of x is equal to 16 times 2x squared plus 19x to the negative 3/2 power. Now we have it in a form where we can use the power rule and the chain rule. So to find the derivative, what we want to do is we start by taking the power up here, the exponent, bringing it down, multiplying it by the 16 times this quantity, 2x squared, plus 19x, all raised to the n minus 1 power. So we're going to subtract 2/2, which will give us a negative 5/2. And then this is the chain rule part. We then have to multiply by the derivative of what's in the parentheses, which will be 4x plus 19. And that is the derivative, but we do want to clean it up a little bit, make it look a little bit nicer. So notice the 2 here in the 16 cancel, so we get 8 times a negative 3 would be a negative 24. And I'm going to multiply that times the 4x plus 19. And since all of this is a negative power, I am going to go ahead and put that in the denominator. So we have 2x squared plus 19x. And it's going to be to the square root, the 5th power. So we're raising it to the 5th power and a square root. And that would be the answer. All right, for the next one, we have a product. We have two different functions here, so we have to combine this with the product rule. This is product rule and the chain rule. So let's start with the product rule. I'm going to let f of x be the first function, 18x plus 13 to the 9th power. The derivative of that then is going to be 9 times 18x plus 13 to the 8th power times the derivative of 18x plus 13 is 18. G of x would be the second function, which will be e to the 6x. And the derivative of that would be 6 times e to the 6x. Now we can put it all together in the chain rule, which is the product rule. Y prime is f prime g plus f g prime. So the derivative would be f prime, which is going to be the 9 times 18, which is 9 times 9 is 81, so 162, times this 18x plus 13 to the 8th power. That's f prime times g, which is e to the 6x, plus f, which is 18x plus 13 to the 9th power, times g prime, which is 6e to the 6x. And then the only thing left to do now is to see if we can simplify a little bit. Let's just try. We have a factor of e to the 6x, which we can factor out. So I'm going to bring out that. I also have a 6 and a 162. And so we can take a 2 out. I can take a factor of 2 out. And I can take a factor of e to the 6x out. And I can also take a factor of 18x plus 13 out. So I could take the lowest power of that would be 18x plus 13 to the 8th power. And so what's going to be left over? Well, dividing 162 by 2 is going to give me an 81. I took all of these out and I took all of this out. Plus, I took 8 of these 9 factors out, so I have 18x plus 13. And I took the e to the 6x out, and I took a 2 out of the 6, so I have a 3. And so we can probably clean that up a little bit. We have y prime is equal to 2e to the 6x times 18x plus 13 to the 8th power. And then 3 times 18 is going to be what? 54x. And then 3 times 13 is 39. And the 39 plus this 81, what's that going to be? That's going to be 1220. So that would be plus 120. And we could leave it like that. Or if we wanted to do it a little bit more, I could multiply that 2 back in through there. But I think that's good enough right there. The next problem, we have chain rule, and we have the quotient rule. So we have quotient rule and chain rule. And chain rule. So in this case, f of x is the numerator, which is the log of 4x. The derivative of that is 1 over 4x times the derivative of 4x is 4, which becomes 1 over x. G of x is the denominator, which is e to the 7x. And using the chain rule, the derivative of that is 7 times e to the 7x. So now we can put that together in our quotient rule. Y prime is f prime g minus fg prime over g squared, which is going to be f prime is 1 over x times g, which is e to the 7x, minus f, which is the log of 4x, times g prime, which is 7e to the 7x, all over g squared. All right, so now we have a little bit of simplifying to do. We have a number of things. First of all, we have this fraction in the numerator. So remember what we do when we have a fraction in the numerator. We multiply the numerator and denominator by what is in the denominator, which is x. So we're going to multiply both of these by x. What we're going to end up with then is this x goes away here, and we're just left with an e to the 7x minus x log of 4x times, I'm going to put this 7 here out in front, and e to the 7x. And then in the denominator, we have x times e to the 7x squared. Now in the numerator, I can factor out these factors of e to the 7x. And then I'm going to be left with a 1 minus 7x log of 4x. And in the denominator, I have x e to the 7x squared. And now this factor of e to the 7x cancels with one of these in the denominator. And that would leave me, let's move over here, with 1 minus 7x log of 4x in the numerator, and in the denominator, x e to the 7x. And the last problem I want to do is an application problem. The sale of mountain bikes over time is given by this function. Determine the rate of change of mountain bikes at time t. That's the first thing we have to do. And then find the rate of change at t equals 0.6. So remember, to find a rate of change, the rate of change is the rate of change at time t, which means instantaneous. Rate of change is the derivative. So this is just a fancy way of saying find the derivative of this function. So the derivative, q prime of t, is going to be, well, the derivative of an exponential is the exponential, but we have to use the chain rule, times the derivative of the exponent, which would be 4t. So that's the derivative, and you just might want to write that a little bit differently, 4t e to the 2t squared. And then we want to find the rate of change at t equals 0.6, at 0.6. So so 4 times 0.6 times e to the 2 times 0.6 squared. And so we could go to Desmos or our handy dandy calculator to finish that off. Take 0.6, square it, multiply it by 2, raise e to that power, multiply 4 times 0.6, and then multiply all those together, and you will have the final answer as a decimal.